In the previous videos, we learned how to divide polynomials using two methods, one of which works for all cases, the other which works for x minus c, dividing by x minus c. And then we saw a remarkable result that when you divide by x minus c, the remainder gives you the value of the function at that point. Now, as the final topic in this particular chapter, we're going to look at rational equations. We saw how to perform operations on rational expressions, adding them, subtracting them, multiplying them, dividing them. Now we look at how to use those skills to solve equations of this type. X plus 4 over 2x plus x plus 20 over 3x equals 3. Now we start with the left-hand side. The first goal is to combine the fractions into one single fraction. Now this goes back to your adding of rational expressions. The LCD for 2x and 3x is LCD of 2 and 3 times LCD of x and x, which gives me 6x. So I multiply this by 3 over 3 and the second term by 2 over 2. So you're already familiar with this concept. Now here I'm introducing a new concept which is called cross multiplication. If you have two fractions that are equal to each other, you can multiply them across and the terms are going to be equal. A times t is going to equal b times c. So in here, I'm going to multiply across in this way. And don't worry, if you don't have a fraction on one side, you can always make 3 into a fraction as 3 divided by 1. So 1 times 5x plus 52 becomes equal 3 times 6x, which is 18x. And then it's your regular linear equation that you can solve and you can verify. General strategy. A general rational equation will look like squiggle over squiggle plus something over something equals something, meaning a combination of fractions and whole terms. Step 1 is you combine the rational terms using the LCD method. When this is done, you end up with a single fraction. This is important. And it should equal some number. Now make sure the single fraction is all by itself on the left side and the other numbers are on the right, because then you can cross multiply. And if you don't have a denominator, you divide by 1. If you have, then you just use whatever you have. At this point, now you have a simple linear equation that you already know how to solve. That is by isolating the variable. Let's look at a few examples. So my strategy says, let's take this term over there, which means I subtract by this on both sides. I end up with x over x minus 3 minus 3 over x minus 3 equals 9. Now the LCM here is just x minus 3. X minus 3 equals 9. These cancel out and I'm left with 1 equals 9, which is an absurd statement. What this means is there is no solution. So you can have a case where you solve and you end up with something absurd, and then it would be a no solution situation. Let's look at the second example here. Now in this case, all these fractions have x terms. So what I'm going to do is I'm going to combine these. First of all, the lowest common denominator for x minus 3 and x plus 3. There's no common factor, so it's simply x minus 3 and x plus 3. Which is also x squared minus 9. Remember? Difference of squares. Okay, so I end up with 2x x plus 3 over x minus 3 times x plus 3 plus 6 times x minus 3 over x minus 3 times x plus 3 equals, I leave the right hand side as it is for now. Then I do my calculations. This is 2x squared. Remember, you're distributing, plus 6x plus distribute 6x minus 18 divided by, now I'm going to write this as x squared minus 9. Okay, so what we have here on the top is 2x squared plus 12x minus 18 over x squared minus 9 plus 28 over x squared minus 9 equals 0. What I did right here is, going from here to here, I added 28 plus x squared minus 9 to both sides. So I have a common denominator, x squared minus 9, 2x squared plus 12x, minus 18 plus 28 gives me a 10 equals 0. Now here I have to make sure that the denominator is not 0. Right? Which means I want to make sure x squared minus 9 is not 0. You factor it out, x minus 3, x plus 3 is not 0. So x is not 3 and x is not negative 3. If a fraction equals 0, it can only happen if a over b is 0, only if a equals 0. So I have 2x squared plus 12x plus 10 equals 0. I notice I can factor out a 2. I have x squared plus 6x plus 5 equals 0. I use my factoring method, split the middle term, and I end up with this. Now this is only possible if one of two things happens. If x plus 5 is 0, giving me x is negative 5. And if x plus 1 is 0, giving me x is negative 1. So that's my solution. Now let's say in an example, I end up with a possible answer as 3. Then I would have to ignore that answer because I already stipulated that x cannot be 3 or negative 3, because that makes the denominator negative. Okay, that's it for this week.